Hello guys, and welcome back in the Robyn tutorial series. I'm your host Christian, and it's been a while since we released the last video on this course. And before starting, I would like to say thank you to each and every one of you guys that have watched the course and took the time to ask questions in the comment, to share your feedbacks. I actually had a lot of people reaching out to me on LinkedIn and Facebook asking for additional consultancy, simply telling me, look, I've seen your course, it's great, it's helpful, and don't hesitate to do that, guys. That's really cool. If you have any kind of questions, feel free to share it in the comment, to reach out to me or whatever. We are so happy to know that our content is actually helpful and helping people with their jobs, basically. Today's episode will be about calibration. So let's start right away, because this is a really cool topic to talk about, and it's something that you should really take into consideration whenever doing marketing mix modeling, and most likely whenever you have the chance to manage your client's budget or your own budget. Because as we will see in a second, calibration will require some additional data that can be basically generated doing some experiments with your budget. So first things first, what we will see in this episode. We will see three main things, because before going into the code, how to calibrate Robyn, I would like you guys to get some context. And since maybe not every one of you is familiar with the concept of Frequentist versus Bayesian models, incrementality testing, we will not cover them deeply into this video, as they are really big topics basically to talk about. So I will just give you an idea of what these things mean, and so that you can get an idea of how the calibration works. And from there, if you're curious, you can let us know down in the comment. We can work on some additional courses specifically about incrementality testing or Bayesian models and so on. But basically, this is all you need to get started with calibration on Robyn. And the first thing is exactly Frequentist versus Bayesian approach, which is simply two different solutions to the same problem. The Frequentist approach, which is the one used by Robyn and used by the majority, I would say, of marketing mix modeling, because it's based on more simple calculations, and so it's somewhat easier to implement and to analyze. And it's based on the fact that the probability of some event is defined by the frequency with which event tends to occur. So, in short, what we do when we use our Frequentist approach is we take a look at the historical data and we try to find a pattern that says, okay, every time I spend 20% more on Google, I will get 10% more sales. So it tries to define this kind of correlations between variables, and it basically learns about the results that are driven by certain actions, okay? And we will see in a second what we mean with doesn't need priors and need priors. But before, let's talk about the Bayesian real quick. And the Bayesian approach, the Bayesian view basically defines the probability of some event by the strength of your belief regarding the truth situation. What this means is that if you have to flip a coin, for instance, okay, and you want to know whether it's going to be head or tail, the Bayesian approach will basically say that you have a 50% chance that you get either tail or head, because that's basically the probability. You have no idea what's going to happen, and you know that's an equal chance that any of the two things will be out of the launch, basically the flip. And on the other hand, the Frequentist will need to look at some historical data, like 1,000 coin flips, understand what happened in each of those 1,000 coin flips, and then it will try to forecast potentially what will happen in the next one based on what has happened in the past. So this is basically a different approach. We can say in really it's take it with don't take it like ground truth, what I'm going to say, just as an idea to simplify this at the most. Frequentist doesn't include probability. Bayesian is all about probability. We can say that, but really there's a lot more to that. So I'd really suggest you to go find some additional contents that more deeply explain this concept if you want to learn more about those. And the difference is probably, the main difference when going to model with Bayesian versus Frequentist is the fact that if you are going to model with Bayesian, you will need priors. So you need to tell your model before starting to model what's the probability that something will happen. On the other hand, with the Frequentist, you are not supposed to know the probability that if you spend more on Google, that's going to drive an additional sale, for instance, because that's exactly something that we are going to try to discover with our model. So this is the main difference. And I'm telling you this just to clarify basically how the Frequentist approach works and what are some other kind of approaches that you could test out. Now, what we can do, since we need historical data basically, and we need to know by the data that we have what happened in the past in order to understand what's going to happen in the future, we don't have priors. We said if you want to calibrate your model, you will need to know exactly how many sales, how many conversions, how much revenue can be attributed to a specific channel during a specific time, okay? You cannot have priors because that's going to be a Bayesian model otherwise, and that's working with different rules, okay? So one thing that you can do is something called incrementality testing. And this is going to give you a clear idea of, in a specific time frame, based on a specific amount of money spent on your ads, what's the incremental impact generated by your media channel. But let's go with this image first, which really clarifies this really well. So first of all, you need to identify your audience that you want to target, okay? And the objective that you want to measure. Let's say we want to measure how many conversions, how many transactions we are generating, okay? We identify our audience and we split our audience into two groups. We will call this a test group and a control group, okay? And before starting to do any kind of tests on this group, we need to watch the groups a little to understand what's going to happen anyway, basically. So even if we don't show any kind of ads to any of these people in our target audience, there's could be some amount of transaction generated, okay? So we want to know how many transactions will be generated without our ads. Once we have this data, which is our baseline, we will go with showing our ads only to the test group and not showing anything to the control group, okay? This can go up for like 1 week, 2 weeks, based on your business, based on the amount of data that you have. You will need more or less time. This is something that you can find out by studying a little bit about incrementality testing. But let's say that we split the groups. We found out the baseline that our audience is generating anyway. And then we provide one group with our ads and one group with no ads. Then we will basically analyze the output of these two different groups. And this way we can know exactly what's the incremental value, the incremental amount of conversions generated by the test group. So if we take this as the baseline that both the test group and control group will generate anyway, this amount here that the test group has upon the control group is basically the incremental lift generated by our incrementality testing. And there are several ways to do this. You can do this people-based, which will be a conversion lift. You can do this geographically based, which is Geo Lift. There are several different techniques. We will not cover this specifically in this episode. Like we said, it's a really big topic to talk about. But just so you understand that this is probably the best way that you have to calibrate your model, if not the only way. as of today. So I would really suggest you guys take a look at this. There is a bunch, like really a lot of contents about this from both Facebook, Google. There is so many articles, libraries that you can use, and it's a really great tool. If you have the control over your budget or your client's budget, that's going to be really easy for you to do this kind of tests once you get the hand basically on how they work. And if not, you can ask your client whether they have done this in the past, maybe with their marketing agency or their marketing team, or otherwise you can try to kind of guide them through the process of implementing this. Okay, so this is basically the theory behind the calibration that we will see right now in this video. And we will take the demo dataset, which is right here. I'm going to zoom in a little. Okay, I think this is good. Okay, so I'm taking the demo dataset. Since the last video, there have been a bunch of updates on Robyn, and currently we are at version 3.6.2. I will suggest you, whenever you see this video, whenever you work with Robyn, to check for updates, because there's been a lot of bug fixes. There have been a lot of new features implemented, so it's always growing basically, and it's really cool to be up to date. So in the demo dataset, this is the latest demo dataset we have in 3.6.2, so this may vary a little if you see this video in the future or you are using an old version. But anyway, I will show you my console first, just to show you what I've done so far. Really simple. I've imported a library, checking the package version, as I told you, is 3.6.2, set the multicore. I'm using specifically Reticulate for Nevergrad. So I do library Reticulate and then use virtualenv or Reticulate Cassandra. Then I'm importing the simulated weekly data, so the demo dataset, and the Prophet Holidays dataset. I'm setting my Robyn object, which is the path where I want to save my final model to my computer, basically. And then first thing I'm doing is simply Robyn inputs. This is the standard setup for the Robyn inputs, and then the other parameters. And then I will do input collect, Robyn inputs with input collect and hyperparameters. And then I will do Robyn run with 2005 trials, and then the Robyn outputs. So this is your standard process for modeling with Robyn, okay? However, if we go back to the source code and we scroll down after the hyperparameters part, okay, right here, you see there is this step 2A4, which is optional, and it's called model calibration experimental input. And basically you have a couple of notes here. As you can see, Facebook strongly recommend to use experimental and casual results, which is considered ground truth, basically, as we said earlier. And they are basically mentioning Facebook Conversion Lift and Facebook Geo Lift. And another thing that you need to note is that if you have point estimate to match your spend, basically, you always need to, and you are spending on average like $100,000 on a weekly basis, and the experimental holdout is on 70%, you need to point estimate the 30K and not the 70K, okay? So besides from that, I've already decommented the next part, which is usually commented in the demo dataset, in the demo R file. And it's this function, which is called data.frame, and it's going to define this calibration input variable. And here, it's really cool because you can set multiple incrementality tests that you have done in the past in one single function, basically. And as you can see, the first thing that you need to define is in which channel you have done the incrementality testing. So for instance, here we are setting 3 different incrementality tests, which are done respectively on Facebook, TV, and then Facebook again. And then you need to set the start date and end date for the lift, which again, just like any other function I will say in Robyn, these are positional arguments. So if Facebook is the first, this first couple will refer to Facebook, the second couple will refer to TV, and so on. So you set start and end date. And then you need to set the basically, in this case, we are working with revenue as our dependent variable, as you can see down here as well. And so this is the amount of revenue attributed to Facebook during this period of testing, okay? This $300,000 is the amount of revenue attributed to TV during this period by the incrementality testing, okay? So this data is what you get out of the incrementality testing. And then we provide the data to Robyn, and then we tell Robyn as well the amount spent during this date. And one thing to note is that, of course, the data of this test must be included in the input data that you are passing to Robyn, and specifically in the rolling window, sorry. So all these dates are inside the rolling window that we are using for modeling, which are defined up here, and it's 2016 November 23 and 2018 August 22. So all these three experiments are inside these rolling windows. And another thing that you need to check beforehand is that the span that you set here is really close to the span that is actually in your data. So Robyn specifically has a 10% margin of error, maybe for approximation and stuff like that. But in short, this data must be inside your CSV file. Of course, this is not. This will be just a part of the revenue generated that day or that week. But for the rest, okay. And the last thing that you need to set is the confidence, because whenever you will do incrementality testing, you will see that you will get out a value, most likely the p-value, which is the statistical significance of your test. And in short, it tells you, if I repeat the same test 100 times, how many times I am expecting to get the same result. So 0.85 means that 85% of the time I repeat the test, I'm expecting the same result. And this is all the p-values. So it's like 1 minus p-value usually to get this the probability of the p-value basically. And so this is the probability for the confidence for each of these three tests. And the last thing that you need to specify is basically the metric, which must match your dependent variable. So if you are doing revenue, it's going to be revenue. If you're doing conversions, it's going to be conversions, or whatever you're using. And after you define this part, you will run the input collection again with Robyn inputs, but this time around you will pass the input collect and the calibration input. So this is going to update the input collect object and set inside the calibration input so that the model gets calibrated. And after that, you will simply run your model again, output your model again, and it's going to be a new model. You can see that I have already done this here. So specifically here, I've set the calibration like I've just shown you in the code. Then I run my models again, and then I have gone to output the models. And let's give it a look to the differences between the calibrated and non-calibrated. So this first folder is non-calibrated. This one is calibrated. Let's take out this file real quick and see which one we like the most. So let me move this here. Okay, so I'm going to over to this real quick. Okay, one thing that I don't like about these first two models is that we have a really basically highly negative trend, like minus 162, and really positive intercept, like nearly 200% here, and pretty much the same here. So I'm going to ignore these first two as I don't really like them. This is a little better. And then we can say that this has the most impact given to, this one. This has the most impact given to the intercept, whereas here the intercept is all the way down, and competitor sales has a lot of impact. And this is pretty similar to this one. So let's go with this one. Let's take this as our general starting point. This is before calibration, okay? And let's see how this changes with the calibration. All right, so we are back in our studio because I had to run my code since I forgot to execute the line to update the input collect. I did Robyn run again, and as you can see, once you calibrate your model, specifically in this case, since I run it with 2,000 iterations and 5 trials, I got a warning message which says, you are calibrating MMM. We recommend to run at least 2,000 iterations per trial and 10,000 trial to build the initial model. I will not do that just for the sake of this tutorial right now, but follow the warnings because Meta team and Facebook team will know better probably. So after that, Robyn outputs just as it is before, and we collect the optimal results, and we can see them here on the left side. I'm keeping these on the right side, which is our non-calibrated chosen model, just to have it as a comparison. And the first thing that I noticed when looking at all these different models is that we don't have any kind of extreme scenarios like we have seen before, where we have like this really negative response decomposition, like minus 150% and plus 200%. So it's more heaven, more settled basically. And I will say that overall the KPIs like R-square and RMSE are the same. But one cool thing to notice is that whenever you do calibration, you get an additional error measurement, I will say, that is called MAPI, which is mean absolute percentage error. So you see here that our this is, I would say, quite a high MAPI compared to what I've seen in the others. Yeah, this one is really cool, like 0.09, and then we have 148 and 149. So I would say this as the lowest MAPI, but again, you need to really use your business knowledge whenever evaluating Robyn's model. So what we can see here, let's compare this to our non-calibrated model, for instance. We see that TV has quite a lot more effects share. The budget is the same, spend share here, and let me zoom in a little on this one. All right, so the budget is the same, of course, but we have like 14% more on the calibrated model, because if you remember, here we are calibrating with one incrementality testing on TV. So probably this model didn't catch TV impact as much well, basically, as this one. We can see the search is pretty much the same. Print here gets some more share, about 2% more, and the out of home gets a lot less. Here we had a 32.8% and we go down to 18%, which is nearly half as much. So probably what happened before is the model overestimated the impact of out of home and underestimated what TV did, because maybe the budgets went higher together, the both of them probably, and the model was not able to capture correctly. But after calibrating the model, we can see that the impact of TV has changed a lot, while Facebook stayed pretty much the same. So we can say that the non-calibrated model catched basically the impact of Facebook correctly. And we can give a look to the others. You see that TV here is a little lower, but still higher than before, basically. And over here we have TV with 45%, which is pretty high, probably the highest of them. 46 here, Facebook is pretty still. This remains pretty still. So overall, what we can say is that after calibrating the model, what the model understood is that out of home didn't actually have as much impact as it thought it have without the calibration, and TV actually had more impact historically based on incrementality testing. And this is pretty much everything for this episode. If you have any kind of questions, feel free to ask them below. I'd really suggest you to go deeper into Geo Lift, conversion lift, and any kind of incrementality testing, because they are super useful. They are privacy proof. They are probably future proof tests. So you'll be able to do them for quite a long time, and you'll see a lot of benefit for this, because even if you are not doing MMM already, even if you are not going to use them to calibrate your MMM anytime soon, because maybe you are working on other stuff, you'll still get data that you can look at and tell, okay, the incremental impact of TV is this. So you'll get a better understanding of what's your business like, what's having an impact on your business, and so on. So thank you so much, guys. Don't forget to subscribe and let us know if you have any kind of questions, and feel free to reach out to me or my team in general. You have all the references below in the description. If you'd like to work with us, if you'd like to get one-to-one consultancy about Facebook in Robyn in general, but even marketing mix modeling in Python or anything else, we are really hoping to hear you guys out. So again, thanks a lot and bye.